Let's start our next topic, which is VRF Lite. So VRF Lite, sometimes we refer it as the a VRF without MPLS. That we will discuss later. I mean, what exactly is the meaning of that? So in the VRF Lite, we do not need to have the RD value. So if you have ever heard about this raw distinguisher, so there is no need of RD. So we will discuss in detail what exactly is this RD and why it is required in MPLS. Okay, so let's see a quick example of VRF Lite. Let me open Paint. So this is our small requirement. Let's say this is our organization wherein we have the LAN. Here we have the LAN, and we have some devices, R1, R2, and R3. Okay. So now let's say we have one more requirement like this. We have one more department. Okay. Let's say we have one more department in our organization that is recently uh, comes into picture, and what we need is this department also needs the connectivity in your organization. So this department, let's say it is a R&D department. Maybe this is the R&D department which is connected to your network. So this is the R&D department that will be connected to your network, and this the requirement of this department is that it is going to communicate within its own domain only. The people who are sitting in the R&D department can only talk to the R&D department. They don't need to go into the production, or also they don't want that the production communicate with them. But the problem here is that we have already used all the IP addresses in our network. Okay, so we don't have anything left for the R&D department, because now you can see the R&D department is connected to our device, but we need to give some IP here, right? So now what we can do is we can create the VRFs, right? If you are familiar with the VRFs, so in VRFs we can use the overlapping IPs, right? So what we can do is, let's say here, uh, let's say I created one VRF here. Let's say I created one VRF named RD, okay, research department. So here also I created one VRF RD. So when I create the VRF, what I can do is I can use the overlapping IPs, right? Let's say uh, the IP here is, in this interface, the IP address is 30.1.1.1. Here we have, let's say, 30.1.1.2. So on this interface also I can use the same IP address, let's say 30.1.1.1. In a normal scenario, when you are not using VRF, then if you try to give the same IP on a different interface of the router, then it will give you an error that you cannot use this IP because it is overlapping with the another interface IP, right? But in VRF, it gives us the permission to use the overlapping subnets. So what we can do is we'll connect this R&D department to one of this router. We'll give the overlapping IPs. Like here, I will use 30.1.1.1. I will connect another cable here, right? So one more cable I will connect here and here, like this. So now what I will do is I will put this interface into R&D VRF, right? this I will put this interface also in VRF, this interface also in VRF, this interface also into VRF, and this one also into VRF, and I can use the overlapping IPs. Like here, if I'm using 12.1.1, here also I can use the same. Here I'm using, let's say, 12.1.1.2. Here also I can put 12.1.2. So now our purpose is solved, right? So now we can use the overlapping IPs, and still the second requirement that was there, that the traffic will not be merged into each other, right? So here, let's say, on the black link we have the production traffic, right? And on the red link we have the research and development wing traffic. So it is not going to merge with each other, right? Because this is the VRF different. This is, let's say, this black is into some other. Let's say it is the production VRF. So the traffic is not going to be merged into each other, right? So this is how we can use the VRF Lite. So let's see it with a quick practical. So let's say we have three devices, router 1, router 2, and router 3. So there are two links between R1 and R2, and there is one link that is connected between R2 and R3. So now what we can do is, let's say we are using two VRF here. So one is the production VRF, and the second one is the RD VRF, which is the research and development wing that we are taking into our example, right? That which is a new department that is going to connect in our network, but these two departments are not going to communicate with each other, right? So here also the VRF will be RD and production, right? So like this. So now let's try to configure it. I will go on R1, let's say here. So we'll consider it like this. So on the upside link, which is the serial 1 by 0, serial 1 by 0 here, there will be production traffic. And on the downlink, serial 1 by 1, there will be the RD traffic, or the newly requirement traffic for the R&D department, right? So let's try to configure it. First of all, let's try to configure the VRFs. I will create one VRF. I will say VRF definition. Okay, and then I just need to write what is the name of my VRF. So let's say I say production. Okay, now I will say I address family IPv4. That's it. What is my second VRF? The second VRF is the let's say R&D. Okay, and address family, I will activate the address family for this particular VRF. Now, what is my IP address? My IP address is, let's say here I'm using 12.1.1.1. Okay, this is serial 1 by 0 interface, serial 1 by 0. I will say no shared, right? Then I will say VRF forwarding. So in which VRF I want to put this particular interface, I want to put it into production VRF. So I will say prod. Okay, VRF forwarding production. Now I will give the IP address 12.1.1.1.255.0.0.0. Enter. Okay. What is my second interface? Let's say it's serial 1 by 1, right? So now, because we don't have the extra IP, so we can use this same IP on the second interface. So I will say interface serial 1 by 1, IP address 12.1.1.255.0.0.0. Okay. Now I need to put this interface into VRF. So my VRF will be R&D, right? Now you can see, as soon as I earlier this interface was into global mode, right? It was into the global. Now we put this interface into VRF now. Because you put this interface into the VRF, now it is no more a part of the global routing, right? That is why it is showing you this, that it is removing the IP address that was configured over it, because now it is not a part of global routing. So now the IP address that you already configured is removed. Now you need to again configure this IP address like this, and you're done. Now if you check show IP VRF interfaces, now you can see that on both of your interfaces you are using the same IP address with different VRFs. So if you're not using the VRF, you cannot assign the same IP address on two different interfaces. It will give you an error of overlapping IPs, right? Now let's move to our next router, that is R2. So on R2 we have serial 1 by 0, which is the uplink that we are going to use for the production traffic. Serial 1 by 0. First of all, let's create the VRF here also. I'll say VRF definition. VRF is production address family IPv4, and the second VRF is RND and address family. Do show history, because these two VRFs we are also going to create on our R3. So that is why let me copy this information there also, so that we do not need to create the VRF again and we can save some time. So now I will go to R2 and let's configure the interfaces now. So the first interface is, let's do like this. Okay, so the first interface, let's the uplink interface is serial 1/0 shutdown. Put it into the VRF. The VRF that we'll use on the uplink is the production VRF, right? The IP address is 12.1.1.2 254.0.0.0. Okay, now let's configure the downlink, which is serial 1 by 1, no shutdown. Will the downlink we are going to put it into which VRF, that is the RND. The IP here also we can use the same IP address, because as we discussed we don't have more IPs to use, right? So we need to use the overlapping IPs. 0.0 shutdown, show IP VRF interfaces. So now you can see on serial 1 by 0 we are using 12.2 IP, serial 1 by 1 also we are using 12.2, serial 1 by 0 in production VRF, and serial 1 by 1 is in RD VRF. Okay, show IP interface brief. Serial 1 by 0, serial 1 by 1, the line protocol is down. So let's go to R1. Show an interface serial 1 by 1. Here the link is down. Let's make it up. Serial 1 by 1, no shutdown. Okay. So now, so we can do two things for this requirement, right? So what we can do is either we can connect, let's say like this, that we connected earlier, one link here and one link here. Or if we are using, let's say we are using the Ethernet connection here, so maybe I can make two sub interfaces, one for the production and one for the RD department, right? And then we can use the overlapping IPs, isn't it, right? So this is what we are going to do here. We are using the Ethernet here. So Fast Ethernet is 0/0.10 we will use for the production traffic, and 0.20 we will use for the R&D traffic. So now I'm at R2. So this side we have already configured. Now what I can do is on fast Ethernet 0/0 I will say no shut. So what interface I need to use? Fast Ethernet 0/0.10, right? I will use this for which traffic? Production. So I'm using the production VRF here. So the IP subnet that we are using is 23. So let's say the IP address is 23.1.1.2.255.0.0.0. Okay, so it is giving us the error that first of all we need to um, put the encapsulation, right? So let's say encapsulation.1q10. Let's give the IP address. Okay, so the IP address is there now. And for our second interface, that is 0.20, that we will use for the R&D traffic. So we'll put the R&D VRF here. The encapsulation we will use is 20. The IP address. So here also we can use the overlapping IPs as per our requirement, right? Sorry, 255.0.0.0.0. Okay, show IP VRF interfaces. So now you can see fast Ethernet 0010 is in production VRF, 20 is in R&D VRF. Now let's go back to R3. At R3 also we'll use the same concept. Interface fast Ethernet 0/0, no shutdown, 0/0/10. VRF forwarding is production. IP address 23.1.1.3 to 55.0.0.0.0. Encapsulation.1q10. Now I will give the IP address. Same we will do for the second sub interface, that is 20, which we are going to use for our R&D department. We'll configure the VRF, set the VRF here. Now give it the same IP address, as we don't have any more IP address as per our requirement. Give the encapsulation first. Now the IP address, show IP VRF interfaces. Okay, great. Now what we can do is, let's say in our network for the production we are already running the EIGRP. Let's say EIGRP 100 we are running in our production traffic. So for R&D we decided to use, let's say, OSPF. Okay, so now let's try to configure this also. I am at R1. So between R1, R2 and R3 over the production on road, I would say between R1, R2 and R2 and R3 we are using the EIGRP, right? So what we can do is, I will go to router 1. I will say router EIGRP 100. I need to say address family IPv4. Then I need to give the VRF name. The VRF name is prod, right? Now here also I need to tell what is the autonomous system number, that is 100. Network, let's summary network, let's say enable it on all interfaces. Show history, right? So on all the three routers we will run the EIGRP on the production traffic, right? So all the interfaces where we are using the production VRF, EIGRP will be activated. Same we will do at R3. Oh, sorry. Let's copy again. I'm at R3. Done. Right. Now you can see the neighborship is up. If I do a show IP EIGRP VRF prod neighbor, you can see R3 is neighbor with R2, or directly we can do the check on R2 because R2 is neighbor with both R1 and R3. Show IP EIGRP VRF prod neighbor. So you can see that the EIGRP neighborship of R2 is up with the R3 and R1. Now what we need to do is, so in the production we are running EIGRP. Now let's also configure the IGP, or say OSPF, between our R&D department, right? So I'm at R1. I'll say router OSPF1 VRF. What is my VRF name for our R&D department? It is R&D. I'll say apply or enable OSPF on all the interfaces where I'm running the R&D VRF, right? So I will say 000 area 0 to show history. I will apply it on R2. You can see OSPF is up. I will apply it on R3 also. Let me copy again. Shortly. EIGRP VRF production. Okay. Show IP OSPF interfaces brief. So you can say here already we are running OSPF, but still the neighborship is not up. Show CDP neighbor, show IP interface brief. So the ports are up. Let's check at R3. Now you can see the neighborship is up now, right? So now let's try to advertise something. So I'm in the production traffic. I'm on the production right now, let's say, and I advertise something into my production environment. Let's say I created one loopback 100 with IP address 100.100.100.100. Okay, 255, 255, 255, 255. Right now, this 100 network will be advertised into the production network only, right? If I check at R2, show IP route VRF R and D, you will not find this 100 network here, right? Because this 100 network we advertise into our production network and we are using VRF. That is why your traffic is not going to mix with this another VRF. This will stay into the production VRF only. So now if I check at R2 in the production VRF with the same output, here also we did not receive it yet, right? Let's go back to R1. Now you can see why we did not receive it. If I do a show IP AIGRP VRF production and interface, so you can see the AIGRP is enabled on serial 1 by 0 only. So we need to also actually EIGRP is enabled by default. If you check here, show run section router EIGRP. So we are using the network 00 command. So by default, the EIGRP will be enabled and it will be enabled where it will be enabled on all the interfaces where we have configured the VRF production. But if we check show IP VRF interfaces, so production VRF is configured only on one interface, not on loopback. So the loopback also we need to put into VRF. Only then it will be advertised. So if I go to show an interface loopback 100, so what we will do is we will say VRF forwarding and the VRF name production. That's it. So it will remove the IP address that we discussed earlier. Now again let's configure the IP address, and now let's check at R2. Now you can see in the production VRF we can see this IP that is advertised into our production VRF. But if I check the same into R&D VRF, there is no 100 network because it is into different VRF, right? If I check here also show IP route VRF production, you can see we are learning the particular route from our production VRF via the EIGRP that we are running into our production network, right? That is EIGRP. Now let's try to advertise something into our R&D department. So I am on R1. I created one loopback. Let's say I created one more loopback. Let's say 11.11.11.11 255 255 255 255. Sorry, IP address. Say like this. And before we configure the IP address, we should have been given what the VRF name. The VRF name is RNT. Now again, let's configure the IP address. Show IP OSPF interface brief. Now you can see OSPF is enabled on our loopback also. So if I go to R3 directly, so what we have done is into our production traffic, because in the production we are using the OSPF. So that particular subnet, that 11 subnet that we advertise into the OSPF domain will stay into the R&D department only. It is not going to mix into your production traffic. So if I check at R3, if I do a show IP route VRF prod, you can see there is no 11 network, right? But if I check the R&D VRF, you can see we have the 11 network. So this is how the VRF Lite works, right? But the problem with VRF Lite is that it is not scalable, right? If you have a large network and let's say you have 20-30 routers, so you need to configure this VRF end to end, right? Let's say you have more routers here, router 4, 5, 6, 7, 8, 9, 10. Let's say you have a large network and you have 30 devices. So end to end, you need to configure these VRF, right? And the second thing is the number of departments, right, that you want to connect. Either you need to connect a separate physical link like this, or you need to create sub interfaces for all the departments that you want to segregate the traffic. So that is why the VRF Lite is not scalable. And the second thing is the routing information must be present on each hop, right? Because let's say we advertise this 11 subnet from here, 11 11 11 11, and if R2 doesn't know in the VRF table, the VRF we are using is R&D. In the VRF table at R2, if this information is not present, then your traffic is going to be dropped. But this is not the case of MPLS. Okay, what happened in MPLS is so in MPLS, we'll discuss the flow, what exactly happens in MPLS. But what I want to highlight here is, let me take the pen. So in mpls you do not need to have all the routes on the transit routers, right? So let's say this is your router R1 and this is your R2 R4, which are your edge routers, and you have connected some devices here. Let me change the color of the pen. Okay, and so you have connected let's say some device here. Let's say it is R5, and at R4 you have connected R6. So now let's say you advertise something from R5 to R1. Okay, let's say you advertise some route, let's say 5.5.5.5. So now this 5.5.5 route will not be present on the transit devices. It will be present only on the edge devices, like this. So this information will be with R1, then R1 will advertise this information to R4, and this is how it works. There will be no information of that of the actual subnets with the transit devices. The transit devices are going to forward the traffic based upon labels only. Okay, so this is that is why mpls is more scalable. Like if you have 50 devices in between, then you need uh, the main configuration only on the edge devices only. So these edge devices we are going to run bgp between these edge devices. Okay, so normally these are referred to the provider edge routers. These will be your customer edge routers, right? So we'll discuss this in detail, how exactly this works at this level and all. So I just want to give you high level information to you that in case of mpls, the transit devices are not going to have the information, right? uh, Unlike the vrf light. So as we discussed about the vrf light, if you don't have the information on the transit devices, your traffic is going to be dropped, right? But this is not the case in mpls. Let's say this interface is going to your customer a, and let's say you are this there is one more interface which is connected to your R7. Let's say this is your another customer, which is customer B. Here also let's say it is connected to R8, and this is also your customer B. So all the routes that R1 will receive into this port, which will be in, let's say, customer VRF, that is VRF A. This port is in VRF B for customer B. Same here, VRF A and VRF B. So all the routes that R5 will advertise to R1, R1 will receive in VRF A, and using the Mpls VPN. So there will be neighborship between R1 and R4. So R1 will advertise all the routes to R4 via IBGP, and these transit devices or routers, they will not be having any information for these particular routes. So they will just switch the traffic based upon labels only. Okay, so that is why MPLS is more scalable, and